When we are looking at scale copies, one of the things that we do is we try to figure out what is the scale factor. That is, what number can we multiply by all of the measurements of the original shape to get us to the measurements of the new shape. So, in this picture, we have figure A that has side lengths of 9 and 3 6/10, and figure B that has side lengths of 3 and 1 2/10. If we want to figure out what the measurements are multiplying by, we have to divide. And when we divide, we take the new measurements and we divide it by the original. So in this case, since A is the original and B is the copy, that tells us that B is our new shape. And we can identify the corresponding sides to help us figure out which measurements go together. So I can see that this 1 2/10 goes with this 3 6/10, and this 3 goes with this 9. Same thing with the other pieces. The top side goes together and the left side goes together. Now, when I'm trying to calculate the scale factor, if I know it's a scaled copy, then I know the scale factor is going to be the same no matter which side I look at. So we might as well look at the easiest side. Might as well use the 3 and the 9 rather than the 1 2/10 and the 3 6/10. So what I'm going to do is I'm going to take the new measurement, which is the 3, and divide it by the original measurement, the 9. Now, yes, it's a fraction, and I could use my calculator and type in 3 divided by 9, which would give me this repeating decimal, 0.333, so on and so forth. But we're just going to work with fractions. I can simplify this fraction by seeing that both of these numbers are divisible by 3, which tells me that my scale factor is 1/3. And if I wanted to check this with the other sides, I could do that. 3 6/10 times 1/3 is 1 2/10. So I'm going to go ahead and enter that as my scale factor. Let's look at another one. So in this shape, just like the last one, it's getting smaller, but this time we need to count our measurements. I can see that these sides are diagonal, which makes it really hard to tell the length of them, but the bottom side I can count. 6 units long and 3 units long. So again, it tells me that B is the copy, which means that it's our new one. So when we do our calculation of new divided by original, I'm going to take 3 and divide it by its corresponding part in the original shape, 6. If I divide it using a calculator, I would get 5/10. If I simplify that fraction, I get 1/2. Both those answers are okay. And what that number tells me is that 6 times 1/2 is equal to 3. Going to go ahead and do one more where we can see the shape getting larger instead of smaller. So what I'm going to do, because I've got a lot of measurements I could work with here, is I'm going to match up the corresponding parts. 14 and 56 both represent that top diagonal side of the shape. 16 and 64 both represent that right side. And 7 and 28 both represent that bottom left side. So I just need to decide which of those pairs I want to work with. And honestly, I'm just going to choose the easiest numbers, which for me are 7 and 28. Again, it's telling me that B is the copy. So that tells me that A is the original and B is my new shape. So when I do new divided by original, I'm going to take the new measurement of 28 and divide it by its matching measurement of 7. Now I could treat this like a fraction and simplify it, or I can just divide it, but either way, I get 4 as my answer. And what that tells me is that if I take any measurement in the original shape and multiply it by 4, I will get its corresponding measurement in the new shape.